last section of this chapter. Applications with exponential functions and log functions. Applications with exponential and log functions. There are basically three categories. Okay. Three categories or three types we're going to look at. One is called exponential growth. Population, bacteria, birds, fish, mice, rats, rabbits, exponential growth. Second one, exponential decay. For example, radioactive substances decrease their mass in time. And the third type is logistic function. You do not have to memorize any of the models. The models will be given to you. Like with the compound interest formula and the continuous compound interest formula, they will be given to you. You don't have to memorize any of this. I would like to start with a logistic function model, an example. Okay, let's look at problems 43 through 46 on page 531. The logistic growth function, p of x, uppercase P, equals 90 divided by 1 plus 271 times e to negative 0.122x. What can you say about this function before we read on? You can say that it has some piece that is exponential. It has some rational. There's a ratio in there. So I cannot say it's a rational function, a pure rational function. I cannot say that it's a pure exponential function. I can definitely say it's a combination. It's a combination with exponential, and the fraction line is here, ratio, and it has some x in the denominator. So it's a complicated function. Not rational, pure, and not exponential. Not pure exponential either. It's a combo. Okay, now let's see what they want and what everything represents. Models the percentage p of x of Americans who are x years old. So percentage and x age with some coronary heart disease, with heart problems. So x represents years old with some coronary heart disease. Use this function to solve exercises 43 through 46. Let's see what they want. What percentage of 20-year-olds, part A, what percentage of 20-year-olds have some coronary heart disease? What am I asked to do? Perfect. So I need to find P of 20. Very good. So this is 90 divided by 1 plus 271 e to negative 0.122 times 20. In part B, they want the same thing for 80-year-olds. So in part B, I will find P of 80. And then part C and D are different. So let's put in the function. We don't have to put it in twice. So let's put it in y equals. And be very careful how. The top is only one number, so I don't need parentheses. But a denominator is a combination, it's a two-term situation. So 1 plus 271 times E. In parentheses, don't forget, negative 0.122 multiplied by x, close the parenthesis for the top, and close for the power, and close the parenthesis for the denominator. And now I go to second and table, and what do I plug in? Exactly, I plug in 20. Oh, okay. I plug in 20, and I plug in 80. So, what is the percentage? If we look at a group, assuming the model is true, and we look at a group of 20-year-olds, how many of them, according to the model, if the model is true, how many of them, I should say, what percentage of that group, if we have 100 20-year-olds, what percentage of that group potentially have, according to the model, a heart problem? Yes, Brian? Okay, so that is 3.655% or 3.66%. Good. Now let's see what happens with the 80-year-olds. Let's go back. So if we have 100 80-year-olds, according to the model, what percentage of those 100 people could possibly have a heart problem? 88.6%. Okay, now let's look at the other problem, the other two. At what age? Is the percentage of some coronary heart disease 50%? Now this is different. At what age is the percentage 50? What am I given now, and what am I asked to find? I'm given X. I'm not given X. I'm asked to find the age for a percentage of 50. So as you see, this is in percent. So 50 must equal 90 over 1 plus 271 e to negative 0.122x. Okay. I'm only going to give one hint, and you'll tell me the next step. Very good. So keep it without distributing this time. So 50 in parentheses 1 plus 271 e to negative 0.122x equals 90. Remember, I'm trying to get here. This is my target. What should I get rid of first? I want to get rid of first of this. Divide both sides by 50. 1 plus 271 e to negative 0.122x equals 9/5. 90 over 50 is 9/5. Perfect. Next. What do I want to get rid of next? Exactly. I subtract 1 from both sides. 1 goes here. So 271e to negative 0.122x equals 9 over 5 minus 1. 9 over 5 minus 1 is 9 over 5 minus 5 over 5, which is? Very good. What do I need to get rid of now? Before I apply natural log. Exactly. I have to multiply both sides by 1 over 271. E to negative 0.122x equals 4 over 1355. Okay, it's completely cleaned up. What do I do next? I turned it off. I'm sorry, it's my phone. I thought I did turn it off. I'm sorry. Don't worry about it. So it's completely cleaned up. I have e to a power and a number on the other side. I need to bring the power down because I'm solving for x. And there is only one function that does that I have to apply to both sides. Exactly. Natural log and natural log. Because the base is e, I will not definitely apply common log. You'll see in a moment why. So what will be the next step? Yes, negative 0.122x. There is no need for parentheses because it's one compact, one term. And then I should write natural log e. But do we remember how much is natural log e? Yes, this is 1. So then negative 0.122x equals natural log 4 over 1355, and I'm done. One tiny step. What is that step? X equals, I need to get rid of this. This wasn't trivial. This is not a trivial equation. So let's look for a moment. This was initially a combination. It's a rational. We cross multiplied, then we got rid of this number, then we moved 1 to the other side, then we divided both sides by 271, we completely cleaned it up, we applied natural log, and now it's finally linear. And I have to plug this in the graphing calculator. Let's do that. So the top, natural log, parentheses, 4 divided by 1355, close the parenthesis, and divide by, in parentheses, be careful, negative 0.122. Close the parenthesis. So now, first of all, let's talk about the answer. The answer has to be an h, right? It cannot be a negative number. So we know that we have 100 people in the room. 50% of them have a heart issue. We want to know how old are they. They're all the same age, 100 people. And we know that 50 of them have heart issue. So we want to know what their age is. So they are roughly 48 years old. So approximately 48 years old. So if the model is true, be very careful. Make sure you take good care of your heart before you get to 48. Any questions? Okay, also, I'm sorry. At what age is the percentage of some coronary heart disease? 70%. Let's do that too. It's a good practice. So now, what do I write? We're talking about 70%. Very good. Equals 90 over 1 plus 271 e to negative 0.122x. Let's work on this for 2 minutes, please. And let me know if you need help. And we'll do it together. That gives me the chance to turn off my phone, right? Actually, I'm pretty sure I did. But of course I didn't. Now it's off for sure. If you need help, let me know. If you get a number, let me know. Do we have an answer? The 8, 50.5?
Yeah.
Okay. We'll do it together in a minute. Anyone else? Anyone else? Is this the only answer? Did we all get the same thing? Okay, first of all, what is the first step? Very good. 70, 1 plus 271 e to negative 0.122x equals 90. Next step. Perfect. 1 plus 271 e to negative 0.122x equals 9 over 7. Next step. 271 e to negative 0.122x equals 9 over 7 minus 1. 7 over 7 is 2 over 7. Yes, because we want to take care of that. E to negative 0.122x 2 over 87, right? 1.8. Yes, okay, yes, just making sure. Sorry. Good, next step. It's completely cleaned up. Apply natural log to both sides. So negative 0.122x equals natural log 2 over 1897. I omitted to write natural log e because natural log e is 1. Perfect. And then the final step would be equals natural log 2 over 1897 negative 1.22. And if this is okay, how much did we get? 56.2. That's the age group. So not everyone is affected, but presumably if we have 100 people age 56, about 70% of them, based on the model, not necessarily true, but based on for each group of 100, it doesn't mean that it's carved in stone, but we expect 70% of them to have some sort of heart issue. So what we're going to look at on Monday is the other two were problems that we didn't get the chance to look at today. The exponential growth and the exponential decay. Okay. And I would like to set up the test 2 weeks from today. Let's see if we can. So that's the target, 2 weeks from today.